Find the mass moment of inertia for the following solids about the axis passing through center as well as centroidal axis. First, long thin rod. Second, rectangular plate. Third, solid cylinder. Fourth, cylindrical shell. Fifth, hollow cylinder. Sixth, sphere. Seventh, thin spherical shell. 8. Disc. 9. Cone.
We will understand mass moment of inertia of different solids. There are two types. Mass moment of inertia about center axis and second, mass moment of inertia about centroidal axis. We will consider mass of each solid is equal to capital M. So first solid is long thin rod whose length is capital L. Now if we observe, here is the center of gravity point G. So we will show the two axes perpendicular to each other and one axis is x-axis and other is y-axis. So moment of inertia about the x-axis is equal to moment of inertia about y-axis, that is Ix is equal to Iy and which is equal to 1 by 12 ml square. Now if we observe moment of inertia about the axis passing through center. So we will show here this axis which is passing through the center of this rod. So suppose this is the center of the rod, then we will show the axis passing through the center. Now what is the moment of inertia about this center axis? So when this rod rotates about the axis, vertical axis which is perpendicular to length passing through center, then in that case moment of inertia is equal to 1 by 12 ml square. Now in this there is second case when this axis is at the end of the rod. So we will show here this axis is at one end. So if I show this axis at one end, then here the moment of inertia is equal to, so it is 1 by 3 ml square. So remember this axis is perpendicular to the length of the rod. So in that case we have to take these two values. So for at the end we will take 1 by 3 ml square, and when this axis is passing through the center of rod, then we will take 1 by 12 ml square. Now we will move to the next solid as a rectangular plate. So this is the thin plate. So its one length is B and other length is C. So here is the rectangle. Now if we observe, we have to show the centroidal axis. So centroid is at the center. So here is the center point. So if we observe, if I draw two lines passing through the center, then it divides this B into two parts. That is, the length is B. It divides into two parts. In the same way, it divides the total length C into two parts. Now suppose if I will say this axis which divides the length B into two parts is the x-axis, then Ix is equal to 1 by 12 mb square. And suppose if I take this vertical line which divides the total length C into two parts, so suppose it is y, then Iy is equal to 1 by 12 mc square. Now if I take the axis which is passing through the center and it is perpendicular to the surface of the plate, then what is the moment of inertia? So I have shown here in the form of dash and dot. So it is passing through the center, but this axis is perpendicular to the or normal to the surface of plate. Then Iz. So if I say this axis is Z, then Iz is equal to 1 by 12 m in the bracket B square plus C square. Next is solid cylinder. So if we take the axis which is passing through the center and which is parallel to the length L of the cylinder and radius of cylinder is capital R, then Iz is equal to half mr square. Now we will select the center of gravity point G. And here are two axes. Horizontal axis is the x-axis and vertical axis is the y-axis. Then the moment of inertia about the axis passing through the center of gravity point Ix is equal to Iy, which is equal to 1 by 12 m in bracket 3r square plus l square, where l is the length of the cylinder. Now second type of this cylinder is the thin cylindrical shell. It is also known as hoop. So here it is very thin. So we can consider as a radius capital R. Then the axis passing through the center and which is parallel to the length L of this cylindrical shell. Then Iz is equal to mr square. Now how to find out the moment of inertia of the axis about any diameter. So I will show that. So this is the diameter of this hoop. Then moment of inertia. So if I draw the axis about any diameter, so this may be the one axis, then here this may be the second axis. So about any axis along the diameter, moment of inertia Iy is equal to mr square by 2. Now next type of solid cylinder we will consider as a hollow cylinder. So for hollow cylinder, inside radius as a r1 and the outside radius as a r2. So if we observe, there is the material which is equal to r2 minus r1. So here is the material. So if we draw the axis passing through the center of this hollow cylinder, and this axis is parallel to the length of the cylinder, and this axis we will take as a z axis, then Iz is equal to half m r1 square plus r2 square. For the solid sphere, we have to calculate moment of inertia about the axis about any diameter. So if we draw any axis which is passing through the center of sphere, then the moment of inertia about that axis is equal to 2 by 5 mr square. Next solid is thin spherical shell. So it is thin, and that's why we will consider the radius of this thin spherical shell is r. Then when we draw the axis which is passing through the center of this shell, then the moment of inertia about any axis is equal to 2 by 3 mr square. For disk, if we take the axis which is passing through the center of disk and which is perpendicular to the surface of the disk, that is Iz is equal to half mr square, where r is the radius of the disk. Now if we take the two axes passing through the center of gravity point, this horizontal axis as a x-axis and this vertical axis as a y-axis, then Ix is equal to Iy, which is equal to 1 by 4 mr square. Now we will move to the cone. So if we take the axis which is passing through the center of the base circle and which is along the surface of the cone, then the moment of inertia about this axis I have shown here in the form of dash and dot. So this axis is z and Iz is equal to 3 by 10 mr square, where r is the radius of the base circle. Now if I take the two axes passing through the apex, this horizontal axis as a x-axis and this vertical axis as a y-axis, then how to take the moment of inertia along this x and y axis. So Ix is equal to Iy is equal to 3 by 5 m into 1 in the bracket 1 by 4 r square plus h square, where h is the height of this cone.